If I were to go back in now, it's like, a lot of shit would scare me. But I'm young and immortal. Thanks for beautiful voice.
Okay, let's start. So we'll have a worksheet here after class, the last 15 minutes. Okay, so let's continue from where we left. So we're doing example number 7 here. So we said you can actually use the row or the column which has as many zeros as possible using the cofactors method. So in this case, we can actually use the first column there. Solution. So if we're going to use the first column, then the determinant here will now be so we take 5, right? And then we multiply by -1. In this case, this is what? 1 plus what? Plus 1. And then the determinant of, we close this and this. The determinant of 3 minus 5 minus 4 and then 7 plus 0. 0 plus the multiplied by the cofactors is what? 0. And then plus 2 multiplied by -1. In this case, this is what? Row number 3 plus column number 1. And then determinant of -2, 4, 3, and -5. Then finally, this is equals to, since 1 plus 1 is 2, then this is 5, and then brackets. 3 multiplied by 7 is 21, minus 4 multiplied by -5 is 20. And then plus, this is 3, 4, this is 2, and then 10 multiplied minus 12 here. And this will give us 5 plus what? plus 2, and this is minus 2. And finally, this is 5 minus 4, which is equals to 1. It's equals to 1. And that is how to get a determinant using the row of column which has as many zeros as possible. Another example, example number 8. Compute determinant of 6, 3, 2, 4, and then 0, 9, 0, minus 4, 1, 0, 8, minus 5, 6, 7, 1, 3, 0, 0, 0, 0, and then 4, 2, 3, 2, 0. Compute. Okay. Using the same way, take the row or the column which has as many zeros as possible. So using the cofactors method, we can use we can start by using the fourth row here. So if you use the fourth row there, then it will now be 3 multiplied by, at this point, this is 1, 2, 3, 4. Negative 1 raised to 4 plus what? Plus 1. And then the determinant of, we close this and the first one there. Determinant of 3, 2, 4, 0, 0, minus 4, 1, 0, and then minus 5, 6, 7, 1, and then 2, 3, 2, and then 0. Okay, so that is the first instant. We continue again like that. So again, you continue like that. So you already done the first one, you continue again reducing this one. So you reduce until you get 2 by 2. Again, you take the one which has as many zeros as possible. So you can use the fourth column there. So actually, this is, in this case, this is 4 plus 1 is what? 5. So this is equals to minus 3. This minus 3 is affecting the whole of it, okay? So it is affecting the whole of it. So then we come to, now we reduce this one again. So we use the what? We use the fourth column here. So 1, and then multiply by minus 1 raised to what? So this is the third 1, 2, 3, the third row. That's what? The fourth 1, 2, 3, 4, the fourth column there. And then determinant of, we delete this and that. So 3, 2, 4, 0, minus 4, 1, and then 2, 3, 2. Okay. So it's like that. So 3 and that is what? Negative, right? So it will cancel with this negative here. So this becomes what? Positive. So 3 is still outside. So 3. And then now, again, we reduce again. So we take the one which has as many zeros as possible. And which one is that? So we can use the first column there. So it is now 3 multiplied by minus 1 raised to 1 plus 1. And then determinant of what? Determinant of minus 4, 1, and then 3, 2. And then plus the next one, the last one here, 2 multiplied by negative 1 raised to what? 3 plus 1 there. And then determinant of 2, 4, minus 4, and 1. Okay, Right. Now, this is equals to 3 is outside, and then 1 plus 1, of course, this will be 3. So 3 multiplied by, now this is minus 8, and then minus 3. Plus, this is 3, this is 2, and then brackets, and then this is 2 plus 16. 2 plus 16. Okay. Now, finally, this is equals to 3. So minus 8 minus 3 is minus 11. So that is minus what? 33. Plus 16 and 2 is what? 32. No, sorry. 16 and 2 is 18. Multiplied by 2 is 36. And finally, this is equals to 3 multiplied by what? 3, which is giving us what? 9. Which is giving us 9. That is how to solve this. You see how short it is. Yep. All of these matches and how we can solve with the determinant. So you take the row or the column which has as many zeros as possible. Since the other zeros will make it to be 0. We'll make it to be 0. Any question after that? Okay, you can try this and then we see what you get. Try this one. See what you get. Example number 9. Compute determinant of -4, 2, 0, 0, 2, 3, 1, 0, 3, 1, 0, 2, and then 1, 3, 0, and then. Okay, let's do that as fast as we can. This one is fast as you can. Is anyone getting to? So again, it is the same way. So I use the first row. So I took -4, and then -1 raised to 1 plus 1, and then cancel, close this and that, this 1, and then plus this 2 here, 2 multiplied by -1, 1 plus 2, and then close this and that, this one. Come to the next one. So when I solve this, this is positive. When I solve this, this is negative. So and then now got this one, and then now I came here. I use this column here. So 1 and then -1. So 1 plus 2, and then close this one. This. All that, and then I came to this -2. Use the same column here. This is first one. Then close this one, this to this, and then now it became 2 by 2. So 2 by 2 is easy to get this out.
Question.
Yeah.
Why didn't you just do row or column 3?
Column 3.
Yeah, because it has 3 zeros. Could you do that?
Yeah, you can also use that.
That's what I
used.
I got the wrong answer. But
You get the wrong answer.
Yeah.
So let's see. You use the row number. This one, right?
column,
So you use this, then use this one. Then it is what? So it is 1, yeah, then -1. And this is what? 2 plus what? 1, 2 plus 3. So it is negative, right? So it's negative. And then you close this. Okay, let's use that. Maybe you found it wrong somewhere.
Say that's what I did, and then I got the wrong answer too, so
Okay, so let's see. There is somewhere you guys went wrong.
somewhere.
Okay, so of course this is, so it is 1, right? Multiplied by -1, and this is 2 plus 3. Determinant of -4, 2, and then 0, 3, 1, and 2, and then 1, 3, and 3, right? And this is of course negative, right? So the whole of it is negative. So it is affecting the whole of it. Get the point? So it is affecting the whole matrix. So negative. And then you come now and reduce this. So which one did you use?
The column.
The last column here, right? So 2, and then multiply by -1. And this is what? 2 plus 3. Determinant of -4, 2, 1, 3. Plus 3, right? 3 multiplied by -1. And then this is what? 3 plus 3. Determinant of -4, 2, 3, and 1. Okay. So we come next. -1 is outside. And then this is what? Negative, right? So this is -2. Determinant of, so it is now -12, -2, right? -12, -2. And this is plus 3. And this is -4, -6. And this is equals to -1. -12 -2 is -14. Multiplied by -2 is 21, 28. Plus -4 -6 -10. Multiplied by 3 is minus. So -30, right? So -30. So this and this is minus 2, and multiply by -1 is 2.
A lot of steps in there.
Yes, so the issue is those signs there.
Yeah.
There's the signs then.
My problem was that I subtracted 2 from 12 and got 15.
Yeah, it happens sometimes. We are in an era whereby we must use a calculator to even solve 1 + 1.
That's what I do. I don't trust my brain.
Yeah, you don't trust your brain anymore.
This can make mistakes.
Yeah.
I was good until I.
So you feel like you can make mistake, definitely. Even if you know 3 multiplied by 3 is 9, you will use your calculator.
Yeah. Yeah. So you make notes and stuff just to be extra sure.
Okay, now let's see how when we have the triangular matrix. So triangular matrices. So if a square matrix A is of the form. So if we have, let's use X and then use star and then 0, 0, 0. You continue like that, 0, 0. Another star here, then another star there, 0, 0, 0. Continue like that, star, star. Continue like that until the last one here is a star there. We have something like that, or if we have here the star here, the star here, the last one here is the star, 0, the star here, star, star. Continue like that, 0, till the last one here is a star. Let's say we have like that, right? Now, if these are below here, below the main, this is the main diagonal here, and then we have zeros above. So this is a lower triangular matrix. If we have zeros here, and then these are not zeros above, so we have the main diagonal here, and all these are not zeros. The upper triangular matrix. Then the determinant here, the determinant of this matrix, then determinant of A is equal to the product of all entries along the main diagonal line of A. So you just multiply the main diagonal entries there. For example, compute determinant of 4, 0, 0, 0, 7 minus 1, 0, 0, 2 minus 6, minus 7, 0, and then 0, 0, or 5, 0, 4, and then 2 there. Compute that. So what you only do here, then what we get is the determinant is 4 multiplied by -1 multiplied by -7 multiplied by 2, which we get 56. So you just multiply the data. 4 multiplied by 1. Okay, so there is the easiest way of getting the determinant of a 3 by 3 matrix. So if you have a 3 by 3 matrix, so let's use this So let's use this one as 2.4. Another formula for 3 by 3 determinants. Another formula for 3 by 3 determinants. So if we have this A11, A12, A13, A21, A22, A23, A31, A32, A33. If we have that matrix, and then you're told to find the determinant. Find the determinant. So the easiest way to do here is you can use the cofactors method, or you can just close. You can just use the example, the formula that we had. So you just use the first row. Or what you do here is you take this matrix A11, A12, A13, A21, A22, A23, A31, A32, A33, and then you add the first two columns here, A11, A12, A21, A22, A31, A33. So you add the two matrices, the two columns there. Then you do what? Then you multiply the diagonal here, multiply that and that, multiply this and this, and then multiply this and this, and then you add them. Okay, then you add them. And then you can come and multiply this and that, this and this, and finally that and that, and then you subtract. So in this case, it will now be A11 multiplied by A22 multiplied by A33 plus A12 multiplied by A23 multiplied by A31 plus A13 multiplied by A21 multiplied by A33 minus A31 multiplied by A22 multiplied by A13 minus A32, A23, A11 minus A33, A21, A12. So that is the easiest way. For example, compute determinant of 1, 3, 5, 2, 1, 1, 3, 4, 2, the one which we have just been doing. So you take this matrix 1, 3, 5, 2, 1, 1, 3, 4, 2. You add the two columns there 1, 3, 2, 1, 3, 4. And then you do what? Multiply that, that, and that. So this is equals to 1 multiplied by 1 multiplied by 2 plus 3 multiplied by 3, of course, by 1 plus 5 multiplied by 2 multiplied by 4. You solve that. Again, you take this like that, and then finally that. This is the same as 3 multiplied by 5 plus 4 multiplied by 1, of course, plus 2 multiplied by 2 multiplied by 3. So what you get here, and this one, you subtract them. So this is 2 plus 9 plus 40. Yep. And this is equals to what? Set 51. Okay, 15 plus 4 plus 6, and that is 12. So 19 is 131 minus, so this is equals to 31. So 51 minus 31 should give us 20, which we have always been getting. Easy. Any question after that?
So for the ones that go up,
Subtract.
you subtract them?
Yeah, so it is basically the same as taking this, and this, that is the first one, minus brackets, take this, and this.
And you add those ones?
So you add this, and this. You also add this, and this,
Okay.
and then you come and subtract. Yeah. Or you can just, because it's just the same as taking this and then minus this one. And when you just open this bracket, this will be minus. Just the same as putting the brackets and then you add what is inside there. Right? Okay, any other questions after that? That one is the end of section 3.1. So the exam will cover up to here. So what we'll be doing here, so we'll do our exam on Thursday.
On Wednesday or Thursday?
You want it on Wednesday or you want it on Thursday?
I don't care, I just
Yeah,
don't know.
either one.
Which
Thursday will be fine.
Thursday will be fine.
If
Okay.
it doesn't affect anybody else.
Yep. Thursday. So I'll ask the other guy. There is a guy who usually comes here for the exam, so he does online.
Yep.
So I ask him when he's available. I put it on 15. So 15, I think is it a Wednesday?
Yeah, 15th is Wednesday.
Then we might have to do it on Wednesday. I will email all of you guys. I'll email the other guy and then I'll ask him when he will be available, Thursday or Friday, or Thursday or Wednesday. But get ready either Thursday or Wednesday. Cool. So let's do 3.2 properties of determinants. Properties of determinants. So we will start from the first one, which is the row reduction method, which we have always been doing all along. The row reduction method. So we know what row reduction means. So basically, when we row reduce, when we were reducing the matrix, so basically you are reducing the matrix completely to what? To the upper triangular matrix, whereby the below the main diagonal were always what? Zeros. So we were forming the upper triangular matrix. Now let's see an example here. Example. And this we are going to see on our elementary matrix. So if we let E to be 4 by 4 elementary. If you still remember what we meant by elementary matrix, what was elementary matrix? So this was the matrix whereby the identity matrix, we do what? We do the row operations. You remember the row operations, like switching, adding the constant. So we form what we call the elementary matrix. Now, if we take here as row operation here, just the way we did in previously, row operation here, and then we have elementary matrix, and then we do the determinant here. Okay. Now, what we do the first one is, let's take, for instance, if we have R2 and then R2 minus 3 R4, okay? If we take the identity matrix of a 4x4 matrix as 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, if we take that one. Now, if we take R2, the new R2 here, and then we take R2, this R2 here, and then we add -3 R4. Then what do we get? So what we get here is actually the first row will just remain the way it is. Then this other one will just be 0, 1, and then 0. And the last one here is what? -3, right? Since we are taking minus R2, the new R2 is R2 minus 3 R4. So basically the last one here is like that. So, and all these remains the way they are. So what is the determinant here? The determinant, we are just multiplying what? The diagonal matrices. So the determinant here of E is equals to what? It's just equals to 1. It's just equals to 1. So it shows that if we do any row operation, if we add to an elementary matrix, it doesn't change anything. It doesn't change. Now, what happens when we switch? Now, let's say we switch R2 and R3. We switch R2 and R3. Then what we get is 1, 0, 0, 0. So we are switching R2 and R3. So 0, 0, 1, right? 0, and then 0, 1, right? And then 0, 0, and then 0, 0, 0, 1. So when we switch like that, what is our determinant? So we cannot do the diagonal because it's not upper triangular matrix. So we can basically use the row, the cofactors model. So we can basically use, let's say we use this, right? So if we take 1, multiplied by -1, and then, so it is 1 plus 1, and then determinant of what is remaining here is 0, 1, 0, 0. Oh, 1, so 1, 0, 0, and then 0, 0, 1, right? So basically this is 1, right? And then we come here, we close, then also this is equals to 1, multiplied by -1, and then this is 1 plus 2, right? And then determinant of, we are using this, determinant of 1, 0, and then 0, 1. So in this case, this is equals to what? 1 and 1. This is equals to -1. So determinant of E here is equals to -1. Determinant of E Are you seeing this? This is 1. 1 plus 2 is 3. Negative 1 raised to 3 is negative 1. And this is 1 and this is 0. So it will give us negative 1. So again, when we switch elementary matrix, when we switch, then the determinant is, it doesn't matter. When you switch this and this, you will still get the determinant. Now, what happens when you multiply by a constant? Now, R3, if we take R3 and then we multiply by 4, the new R3, and then we multiply by 4. So when we multiply by 4, R3, so 1 0 0 0 0 0 0 1 0 0 0 0 4 0 0 0 0 and then 1. So of course, determinant here is what? Is equals to 4. Is equals to 4. So determinant is equals to 4. Remark. First remark here. If we let E be an n by n elementary matrix. Number 1, if E is obtained by applying Rj to get Rj plus C Ri, where I is not equals to J, then determinant of E is always equals to 1. Just the way we just saw it there. That's the first one. Number 2, if E is obtained by applying Ri when we switch and Rj, where I is not equals to J, then determinant of E equals to negative 1. Then number 3, if E is obtained by applying Ri to get Kri to actually identity matrix, let's say In, then where K is not equals to 0, then determinant of E is equals to K. Is equals to K. So those are the main issues. So basically, number 4, the elementary matrix E is invertible, and determinant of E is basically not equals to 0. Now, this is taking us to another theorem here, which we are going to apply this elementary matrix. We are going to apply this elementary matrix. Let's take theorem 1.1. And if B is the matrix obtained by applying some elementary row operation, which you can name this one as op, to an n by n matrix A, and E is the elementary matrix obtained by applying operation to identity matrix IN, then B is equals to EA. B is equals to EA. And determinant of B is basically equals to determinant of E multiplied by determinant of E. Determinant of E multiplied by determinant. So to prove this, we are going to use the three elementary operations there. So we're going to use the three elementary operations. Okay. What we are going to do is we're going to use a 2 by 2 matrix in this case. So let's prove this. Okay, let's prove. If we consider A to be A11, A12, A21, A22. Let's consider that A to be that. So determinant of A in this case is equals to what? A11, A22 minus A21, A1, A12. That is that. Okay, if we start from that. Now, let's start case 1. Case number 1. Now, if we do the operation, if we take the operation, and what we do the operation on the elementary, on the identity matrix over 2 by 2. In this case, let's switch R1 and R2. Let's switch R1 and R2. Let us switch R1 and R2. Now, since we said B is the matrix obtained by applying some elementary row operations on n by n matrix A, we have this A here. Then our B in this case will be what? We are switching this. Will be A21, A22, A11, A12. Okay. And then elementary matrix is what we get when we do what? We do the row operation on a 2 by 2. That means we are switching again this one. So it is 1, 0, 0, 1. So it will now be 0, 1. And then this one is 1, 0. Now let us see if B is basically equals to EA. So we want to see if B is equals to EA. Then we know so we want to see whether B is equals to EA. So we have our A is this. So we have our A, which is so we have our E, first of all, is 0, 1, 1 and 0. And then let's multiply this by A11, A12, and then A21, A22. Okay, let us multiply that. We see whether we will get this B here. So if we multiply this, then this is this 0, this and this is, so it will give us A21. This and this is 0, this and this is A22. This and this is A11. Of course, the last one is A12. Is it equal? So it is equal, right? So B is equals to EA. B is equals to EA. Now, What is the determinant of B here? So determinant of B in this case, determinant of B is equals to A21, A12 minus A11, A1, A22. It should be equals to. Now, what is the determinant of E in this case? -1, right? -1. So -1, and then determinant of A is this. A11, A22 minus A21, A12. Basically, they are equal, right? Because when you open these brackets, it is equals to this. So they are equal. Now, the next one, if we do the row operation, we have 5 minutes. Oh, we still have 10 minutes. Then I give you your worksheet here. Case number 2. Now, if we do the operation on whereby R2, to get new R2, we get R2 plus CR1. R2 plus CR1. Now, for our B, it will now be what? Of course, we retain, so we are doing the row operation, so we retain A11, A12, our new R2 there will be R2 plus CR1. So R2, which will now be A21 plus CA11, and then A22 plus CA12. That is what we get. Now, if we do the row operation on the identity matrix, which is 1, 0, 0, and 1, whereby we are, so our E here, so this is our B equals to that. Our E in this case is R2 plus that. So it will basically be, our E in this case will be 1, 0, and then this will be what? C, right? C. And then the last one here is 0 or 1. This one. Right? Right?
Yeah.
Yep, it is 1. Now, when we multiply this and A, when we multiply this one and A, which is A11, A12, A21, and then A22, are we going to get this? So, of course, we are going to get this one because it is 1, and that is A11. This and that is A12. Then this and this is C A11 plus A21. And then finally, this and that is C A12 and then A22, which is the same. So basically B is equals to E and then A. If we do the determinant here, then the determinant in this case, the determinant of B is equals to what? A11 multiplied by A22 plus CA12 minus A12 multiplied by A21 plus CA11. And what we're going to get here is just the same as the determinant of A. We're going to just get the determinant of A. So it will just be the same as determinant of E, determinant of A, because determinant of E here is 1 and 1 there, which is equals to what? 1. And then determinant of A. So when we open these brackets, it will just give you this determinant of A here. So it doesn't change. So when we add the constant, it doesn't change the determinant. Now, finally, if we now put If we now multiply by a constant, case number 3. Case number 3, we do the operation whereby our new R2 is we multiply K R2. Multiply K R2. Then, of course, our B will be what? Or B will be A11, A12, and then KA21, and then KA22. And then our E will definitely be 1, 0, 0, and K. 0, K. So, of course, this is equals to multiplying by A, which is A11, A12, A21, A22. It is the same as multiplying by this. Determinant also is of B is equals to determinant of E. Determinant of A. They will be the same. Finally, since determinant of B is equals to determinant of E, determinant of A, determinant of E, determinant of A, then to get the determinant of A is equals to 1 over determinant of E multiplied by determinant of B, multiplied by determinant of E. E is equals to determinant of B if the operation is Rj, whereby Rj plus C Ri, and I is not equals to J. Okay, so because this will just be 1. Negative determinant of B if the operation is actually Ri, you do what? You switch Rj, where I is not equals to J. And finally, this is equals to 1 all over K, determinant of B if the operation is Ri, whereby K, we multiply K by Ri, where K is not equals to 0. Is not equals to 0. Okay. So that is any question up to that? Now, before I give you the worksheet, then lastly, if B is obtained by multiplying every entry in the ith row of A by a non-zero number. Okay, then the determinant of, let's say, A11, A12, all the way to A1n, and then here KAI1, KAI2, all the way to KAIN, and then here, so it continues there, and then AN1, AN2, all the way to ANN. Have that. Then this is equal to factoring out K and then getting the determinant of A11, A12, all the way to A1n, AI1, AI2, all the way to AIN, and then AN1, AN2, all the way to ANN. So it is basically similar to that. Similar to that. where in this case, Ri is basically 1 over k, and I where k is not equals to 0. K is not equals to 0. So we'll see some of the examples on this application here in our next. Yeah. This would be so easy. So you can just remove. It's the number of yeah.
I hadn't caught up on yesterday's. Okay, so
This is the number of two dimension. Actually, the dimension is the number of vectors.
okay,
So the number of vectors two
2 and 3.
and three.
Okay.
And this dimension of columns is also the dimension of
So it's
the
that
dimension of column. So it's
R4.
three as well.
Oh.
So it is build this one and then the last one here is the number of vectors in the columns which are there for that.
Okay.
So it's
What's the notation for?
so the D-I-N and then
Dim of column. No,